Flexbox is a fairly new layout mode in CSS, and it gives us a lot of new properties that can be adjusted to output a wide variety of layouts. By default, content on a page flows vertically from top to bottom. In this example, we have an unordered list of links, similar to something that could be used as a web page navigation. I'm going to go ahead and remove the bullets from the list by setting list style to none on the unordered list. Then I'll set display to flex. Flex will leave this unordered list as a block level container and will affect the layout of its children. If I wanted the container to be an inline element, but also wanted the contents to be displayed using Flexbox, I could change display to inline flex. Both flex and inline flex will lay out the children the same, but flex makes the container a block element, breaking the horizontal flow with its siblings, and inline flex, like an image tag, will not. Notice when I added display flex that the links changed orientation to be laid out horizontally. That's because Flexbox containers have a property called flexdirection, which defaults to row, which, like the rows of a table, are laid out horizontally. I can change it back to a vertical layout by changing flex direction to column. Additionally, I have two alternative layouts which affect the order of the children. Column reverse will cause the children to flow from bottom to top, and row reverse will lay them out from left to right. Flex direction is most useful in the context of a responsive web design. When combined with media queries, it can adjust the layout direction of the children based on the size of the window. Currently, I'm working on a website that has a horizontal navigation, but when the window size is closer to a mobile screen, the navigation is laid out in a vertical list to make better use of the screen real estate. It is important to note that many Flexbox properties, including flex direction, need prefixes for some browsers. Make sure to double-check documentation, or better yet, use the auto prefixer post-CSS tool to automatically add the needed prefixes. On children of Flexbox containers, we can adjust the order property to affect the order in which the children are displayed. Let's look at an example. Here are four primary sections on the page: a header, a navigation, the content, and a footer. I'm going to uncomment this block to add some background colors to make it easier to distinguish them. We're going to use the order property to implement the footer anchor UI pattern, where, on smaller screens, the main navigation is moved to the footer of the page to free up some real estate in the initial view. First, we need to change the container's display to flex. In this case, it would be the body tag. We still want the content to flow vertically, so let's change flex direction to column. Now to reorder the elements, we need to change the order property on the individual children themselves. Order defaults to 0. And when multiple children have the same order value, those children are laid out based on the order they appear in the DOM. So if I change the order to 1 on the main nav, it jumps below the rest, which have an order value of 0. If I wanted the nav to appear just above the footer, I would need to adjust the footer's order value to 1 as well. Negative values are also allowed, which would let the navigation jump above the rest of the 0 order elements. The Flexbox layout gives us a lot of options for changing the alignment of elements within the Flex container. It actually gives us so many options that it's easy to confuse them. So let's demystify them by looking at some examples. Here I have 3 articles of different sizes with headlines. I've set the background color of the body to this dark gray, so it makes it easier to see the boundaries of the article elements. I've already set display to flex on the container, which in this case is the body tag. I also set the flex direction to column, so the content flows from top to bottom. The first property we'll look at is justify content. This property affects the way the children are aligned along the direction the content is flowing. Currently, the flex direction is set to column, so justify content will affect how the articles use the extra space from top to bottom without adjusting the actual size of the elements. Justify content defaults to flex start, which means they will all bunch up to the starting point, which in this case is the top. If we change it to flex end, they will bunch together at the bottom. We can also change it to center to get them to bunch together in the middle. This is also a great way to finally get real vertical align in CSS. If I only had one child or one article, it would still be centered vertically. I can also spread the children out using space between, which will stick the first child to the start of the flow and the last child to the end, with the children in between spaced out evenly. The last option for justify content is space around, which is pretty complex. It distributes the empty space equally around all the children, including the first and last ones. But notice the space before the first child and after the last child is half of the space between children. Justify content affects the space along the flex direction. Align items affects the space perpendicular to the flex direction. To illustrate this better, I'm going to change the direction to row. I'm also going to make all the articles the same width by setting flex to 1 on all of them. Now we have 3 articles of different content length, but their box height is the same. They're stretched to 100% height. That's because align items defaults to stretch, which will use all of the extra perpendicular flex direction space, which in this case is the vertical space. We can also set it to flex start, which will move them to the top. Flex end will align them to the bottom, and center will move them to the center. This is also another solution for the CSS vertical align problem. The last option is baseline. This will align the items to the baseline of the first line of text in the element. I can better demonstrate by removing the H1 tag from this last child. Notice how the baseline of the first line of the text lines up with the headlines in the other elements. I can also change one child individually by using the align self property on one of the children. Align self is identical to align items, but you apply it to a Flexbox child as opposed to the container. And it defaults to auto, which means do whatever align item says. But if I wanted this not real article to align to the bottom without disturbing the other ones, I could set align self to flex end. So a quick review. Justify content declares how to use the extra space along the direction the content is flowing. Align items declares how to use the extra space perpendicular to the flex direction. Align self is the same as align items, but where justify content and align items are applied to the Flexbox containers and affect all children, align self is only applied to specific individual children. The most flexible part of Flexbox is the sizing. We use 3 properties to handle the resizing of Flexbox children along the flex direction: flexgrow, flexshrink, and flexbasis, which are all applied to individual flex children and not to the flex container. So let's start with flexbasis. With flexbasis, you can define the optimal size of a child along the flex direction. Let me explain what that means with an example. In this example, I have 3 H1 tags with different background colors to make them distinguishable. I can set display to flex on the parent container, in this case it's the body tag, and notice that even though H1s are block tags that usually have a default width set to 100%, they shrink down to the content width here. Let's dig into the complexity of how the width is determined. If I set a width on this first child to 200 pixels, it will respect that width. But if I set the flex basis to 150, it will override the set width. But note, it will not exceed the max width or go under the min width. In essence, what is happening here is a cascading hierarchy. If flex basis is not set, it defaults to auto, which means look at the dimension corresponding to the flex direction. Since our flex direction here is row, the corresponding dimension is width. If width is not set, it defaults to the content width of the element, which in this case is just the size of the word. Because of the complexity this hierarchy can introduce, I recommend sticking with flex basis, not setting a width for all Flexbox children in row flex direction, or height for all column flex direction children. It makes it easier to know where your dimension is being set. So flex basis is the ideal size for the element along the flex direction if it has enough room. To figure out what happens when we have a surplus or deficit of space, we need to understand flexgrow and flexshrink. To make flexgrow and shrink easier to see, I'm going to give each of these children a different flex basis. I'll set the first to 120, the second to 40 pixels, and the third to 100 pixels. Now look, I have extra space in the Flexbox not being used by the children. The flexgrow property dictates how that space should be divvied up by the children. Flexgrow defaults to 0, which means none of these children will grow beyond their flex basis. If I set the flexgrow of the first child to 1, it will use up all the extra space without affecting the width of the other children. This 1 does not have a unit, it is a proportion. It is a 1 to 0, in this case 100%. It is using 100% of the extra space. If I change the flexgrow on the second child to 2, now the first child is getting 1/3 of the extra space and the second child is getting 2/3. If I set the flexgrow of the third child to 3, now the first child gets 1/6 of the extra space, the second child gets 2/6 or 1/3, and the third child gets 3/6 or 1/2 of the extra space. If instead of divvying up the extra space, I want to divvy up the total space, I could set the flex basis on all the children to 0, which would make the total space the same as the extra space since none of the children are taking up any space. Flexgrow dictates how the extra space beyond the combined flex bases should be divided up. Flexshrink defines what should happen when there is a deficit in the combined flex basis values, meaning if the combined flex bases is greater than the allowed space, how do these elements shrink? For an example, I'm going to define all the flex basis values to be 200 pixels, so the combined width will exceed the width of the container. Even though they are too big, they're all losing some width because the default width of flexshrink is set to 1, meaning all children shrink the same amount from their flex basis values. If I set the flex shrink of one of the children to 2, it will shrink twice as much as the other children. I can set it to 10 or even 100, but notice at some point, it does not go past the width of the content itself. If the other children have non-content width they can spare. The emphasis here is content should never be clipped for the benefit of empty space. Now, if I don't want a child to shrink at all, I can set the flex shrink to 0. In fact, if I set the flex shrink to 0 on all of them, they will cause the container width to overflow. There is also a shorthand for these 3 values. I can use the flex property that lets me pass 3 values, flexgrow, flexshrink, and flexbasis, all space delimited. But there are multiple configurations of these things, and the defaults are different in this configuration just to mess things up. Let me show you a couple examples. So in this example, flex is set to 1, which it doesn't have a unit, so it gets passed through to the flexgrow property. Flexshrink is also set to 1 because that's what the default is, and flexbasis is set to 0, which is unusual because flexbasis usually defaults to auto, but in this syntax, if flexbasis is not defined, it defaults to 0. In this next example, flex is set to 20 pixels. Because it has a unit of measurement, the only value that could be is flexbasis. So flexgrow defaults to 1, which is weird because usually it defaults to 0. Flexshrink still defaults to 1 here, and flexbasis gets that 20 pixel value. Here, in this example, I'm defining a unitless measurement first, and then I'm defining a measurement with pixels on it. So flexgrow gets the first measurement, which is 0. Flexshrink gets 1, still default, and flexbasis gets that 80 pixels. What's important to notice here is that the flexgrow and the flexbasis defaults are different when you use the flex shorthand notation than when you use the flexgrow and flexbasis notation. What's nice about this shorthand is if I set all the flex properties to 1, which means a flexgrow of 1 and flexshrink of 1 and flexbasis of 0, it makes all the children the same size and all grow to use all the space, which is something you'll find you often want to do with Flexbox. Adding wrapping to a long Flexbox list can give you some nice grid-like features. So in this example, I have 7 images from Unsplash, each with a caption of the photographer. So let's start by setting display flex on the main container. In this case, it's the body tag. And let's fix the width. Right now it's set using the width property, but I'm going to uncomment this flex property to keep it more Flexbox friendly. Also, the flexgrow here is set to 0, so it doesn't get away from us. Now we can see the list of images flow horizontally, which is fine, but we don't really want it to go off the page. So let's add flexwrap, which defaults to no wrap, but let's set it to wrap. There's one other option. We could also set it to wrap reverse, which causes the line breaks to flow up instead of down in this case. Notice the content bunches up to the top left corner. If we want to spread it out a bit, we can add justify content, space around, which we know will give us some nice space along the flex direction axis. And it also affects the alignment of the orphaned item on that last row. But that doesn't really help us with our vertical rhythm. So we can add aligncontent. It has values that we're already familiar with. Flex start, flex end, center, space between, space around, and stretch. But stretch isn't going to show much because we have a fixed width and height. Align content is only used with multi-line content, and make sure not to confuse it with align items or align self, as it won't do anything on single line content. Flexbox has a lot of power, but it's only useful if we can use it in real websites and applications. We're going to look at a couple of ways that Flexbox can change the way you can lay out an actual application. I started with Dan Abramoff's sample to-do application that he made for his Redux series. I added some classes to make it easier to style, but other than that, I tried to leave the JavaScript and the markup alone and just mess with the CSS. So this root element is the main container for the application. I didn't want the width to get too big, so I set the maximum width to 720 pixels, but I want it to take up all the vertical space, so I set the max height to 100 vertical heights, or VHs, which is essentially 100% of the vertical height. And I wanted to push the content down to the bottom. So even though root only has one child, I set the display to flex and I set the flex direction to column. And then that allows me on the larger screens to set the justify content to flex end to push all the content down. And then on the smaller screens, when it's less than 730 pixels, it goes back up to the top, which is the default, setting it to flex start. I also want the order of these elements to change between the large and the small screens. So the default has this filters box at the top. Using the order property, I set it to -1 to make sure that it stays up at the top. And then on the larger screens, I set filters with the order to 0, and essentially do the same thing with the to-do list, just swapping them. So this to-do list, which is the list of these items here, it's -1 on the larger screens, making sure it stays at the top of the list or the top of the elements. And then I set it to 0, making sure it stays in its normal place, which is below this new to-do item and below the filters. I could also do the same thing using the flex direction and change it between columns and columns reverse. In fact, I do that with the list items. So when I type in a new item here, while it's the top-down view, I want the new item to show up right underneath. And when I'm using it on the larger screen, I want the new item to show up right above it so that it's always close to that box that you just typed in. And I do that using the flex direction column on the to-do list. And up above on the smaller screen, I have the to-do list with the flex direction of column reverse. There are some layouts that you don't even need media queries to reap the responsive benefits of Flexbox. I used Flexbox in several places on the recent PhoneGap.com redesign. And you can see at the very bottom I have a collection of lists. And as I resize this window, these lists will take up the space appropriately, and then it will actually break. So it'll use up as much space as possible, and then using flexwrap, it'll actually move to the next line so it doesn't overlap on itself. And I'm doing some similar things up here with this grid-like system. I'm just using wrap to use up all the available space. So I'm not even using media queries heavily to make that happen. I'm just using Flexbox and flexwrap. And with the ability to reorder children, wrap elements, and divide up space on a collection of dynamic children, Flexbox is an essential layout tool for responsive applications and websites.